Hello friends, in this video I'm going to be showing you how to query use analytical functions mainly. So here's my example. So let's assume we have a table called produce, okay, and we have all these produces. We have kale as an item and how much is the price for it, or how many were purchased, and what kind of thing it is, vegetable or a fruit. So as you can see, uh, let me show you some simple ones here. This is what you will see if you run a select star on a SQL like this, right? Okay, so here's my table. I'm just going to arrange this window a little bit so we have more space. So this is the query. So what I'm showing you here is a simple select star, okay, which is going to just show me the data that I have right now. So we have 6 rows of data, and this is what we have. Now in analytical functions, we can do things like, for example, we wanted to see what are the total purchases, right? The sum of the total purchases um, for every single item. We also want to know the total purchases, not just the total. If I just want a sum, I could have done select sum purchases, but I want to know, like, even for kale, like I want to have another column. What analytical functions really do is they add columns, okay, to the existing same amount of rows. So here's an example we could do. I'm going to comment this one out. That's the way to comment it. And I'm going to, with the same data, I'm going to show you where I'll select the same item, the purchases, the category. But in this, what the analytical function I'm using is I'm doing sum purchases over everything. This is how you write an analytical function, okay? So sum is the analytical function. What this will give me is 6 rows of data back, same amount of rows, but it will tell me the total is 54. How did it get 54? It's like 23 plus 2 plus 9 plus 8 plus 2 plus 10 is 54, and it's giving me that number for every row. And if you need to do that, this is the use case of analytical functions. In analytical, if you're using analytical functions, you cannot use group bys. So that was one example of an analytical function. Let's do another one. So this is another one. We're doing some purchases, but we are going to now use the partition by category. So we want the total sum of the purchases, but by each category. That was one number 54 in every single row, right? But we want it by category. What is our categories here? We have fruits and vegetables. So within the fruits, what was the total purchase? And within the vegetables, what was the total purchases? So this is what this one will do. Let's run it. So what I see here is, for fruits there were two fruits, orange and apple, and there were two purchases of orange and 8 purchases. So that is 10, and 44 for the vegetables. It's basically the same 54, but split by the categories. So this, and how do you do the split while summing? How do you do the split? With the partition by clause. This is very important. This is what this partition by does. Okay, so that is the second example. I'm going to comment this and show you a third example, which is this one. So this one. In this one, what we're doing is we're selecting item, purchases, the category, the same thing, all the three things, and we're summing purchases. But what are we doing here? We are doing partition by category, order by purchases. What did we do in the previous example? We did partition by category, order by purchases, and we did rows between thing. So this is actually the same query, okay, but I wanted to show this again because I want to talk about this rows. You're ordering by the purchases and you're doing rows between unbounded preceding and current row. This is how you write how many rows forward or backward you want to look at. So this is a very important one. You can say rows between one and the current row or something, right? Like one above and one below. You can say. I'll show you a simple example. Um, so here, what we are saying is limited to the current row. So if um, we are ordering the purchases, we only want the purchases that are less than, summing up to less than, not like all the things. So let's just run it, and I'll show you what this means. So here's an example where I'm showing you where we are doing preceding, unbounded preceding, but only but don't look further. So what the difference between the previous query? In the previous query we were getting 10 for both these fruits, right? Because when we order by the purchases, we were looking at everything, unbounded preceding and the current row. But here we are looking only unbounded preceding and the current row, but not like one below, like not adding everything. So what I mean by that is, see over here, rows between unbounded preceding and unbounded following also. But in this we are doing rows between unbounded preceding and the current row, only up to the current row. So that means we're going to take all. What the sum purchases does is it takes all the data by the category. So we're going to sum the purchases, but by the category. We're also going to order the purchases. While doing that, you will order them, and and when we order, we can look at all, or we can also say now after ordering, add additional thing where you're only going to look at number of rows up and down, right? Like previous rows and bottom rows, you can say. In this case, we are saying unbounded preceding and current row. So don't add uh, things that are above, like below the thing. So that's why 8 has a value of 10, but 2 does not have, because when you're aggregating for orange and you're sorting it, you're looking at the category fruit, but you're only going to look at the current row. So you're not going to look below. That's what it's doing. So let's look at the vegetable example. In vegetable, leek is first, right? Because first what you do is by category. So these are already sorted. These 4 columns are in the order, right? These are all vegetable category. And now the second thing we said was order by purchases. So this is ordered. After ordering, what we are saying is rows preceding unbounded means preceding means above it, before it. So before it, count everything before it, but only up to the current row. Don't look after ordering. If you're looking for cabbage, don't consider lettuce and kale. And if you're looking for leek, look everything above and don't consider cabbage, lettuce, kale. Okay, so just till the row. So for leek, unfortunately there's nothing above it, it's the lowest one, so the number is the same. But for cabbage, after sorting, we know there's leek, which was less purchases more than cabbage, so we sum that up. For lettuce, we know that what was everything above lettuce, meaning all leek and cabbage, but not kale. And for kale, it means everything above and itself. Okay, so that's what the thing is. So these are the basic thing is this. This is the most important thing. The syntax is whatever the function, you can do sum, you can do um, row numbers, you can do like giving it row numbers by partitions by categories, you can do lag, you can do last value, many things you can do. You can use any function here, and you need to say partition by category. So you're looking at, so these are very useful. And order by purchases, you want to order it by purchases, and rows between unbounded preceding and the current row. Let's look at another example. I'm going to show you a piece of code. Tell me what this code does. Let's review it. So whatever I'm uncommenting is what I'm showing every time. I I think we're discussing. So let's see this one. So here we have item purchase category. We're doing some purchases over partition by category. So that means there will be two sets, right? There will be fruit and vegetable. And within that, we are saying um, purchases and ordered by the purchases, and then we're saying rows unbounded proceeding. Okay, so let's run this and see. So this gives the same value because we are not saying unbounded. We said the same thing. We said rows unbounded proceeding. The only thing we didn't say and current row, right? We didn't say that, but we don't have to say that because if you don't say that, it's by default you're only looking up to the current row. So that's what this is. Proceeding between, we said between unbounded proceeding and current row. Here we are not saying between, we are saying rows unbounded proceeding only. So we can say between or things like that. Now let's look at this example. Now let's look at this one. Okay, and let's see what this one is. So here we are doing item purchases category, some purchases over. Okay, what are we doing by? We're not splitting by category at this point, looks like. We're not saying partition by. What's missing here is we don't care. We want to sound like we want to do it, but we do want to restrict. We want to order by purchases, and we want to restrict to rows between unbounded proceeding and to proceeding. So let's take a look at this. So we're not doing by category. So this one, what this allows us to do is we're going to order them by purchases, right? Which is what we did. But rows between unbounded proceeding and to proceeding. There has to be to proceeding. Only then start giving me a value. This is what it's saying. It is very cool. As you can see, then we don't give value to the first two. So these are some examples. Most importantly, the most simplest thing to remember is what are the things you need to write. You need to write, like, you can use average purchases, for example, or sum. You say partition by, order by, rows between, and you can say one preceding and one following, or you can say, how many ever choices. You can say between unbounded proceeding and you know current row, things like that. Here we are doing the last value. We're trying to find the last value. Let me show you the last value because that's a very good one and you're going to keep getting asked about that in interviews. So let's try the last value one. So what we're doing here, we are also trying to define a window. And how do you define a window? But basically partition by category, order by purchases. So as you can assume, what will this do? This will give you the most. So what we're doing is we're partitioning by categories, ordering them by purchases, and give me the last value of the purchases. You can do like that. So this is basically going to give you the most popular thing. Okay. For each category, it's going to give you the most popular food. This is how you do the most popular food. Most popular, but also there's one more condition: most popular out of the one above and one below proceeding. So in this case, vegetable is the first, leek is the first vegetable, but we are looking at one above and one below. But because cabbage has the thing, it will get cabbage obviously, and we are sorted, right? So it's kind of a way to also get the get the next value. So here, if you're doing for lettuce, you'll get kale, and for kale, you'll get kale. So that's it. Continue watching, I'll cover more in the next few videos.